Welcome to the next lesson in this chapter where we will be talking about health checks, why they are valuable in general, and how you can easily implement health checks in ASP.NET Core. This is going to be one of the shorter lessons in this chapter, but nonetheless valuable. So I'm going to start by adding some NuGet packages in my infrastructure project. Let's look for health checks, and you will be able to see many health check NuGet packages with the name ASP.NET Core, health checks, and then something. If you take a look, here is a health check for SQL Server, Redis, a health check using a URI. There is also a health check for MPG SQL, RabbitMQ, MongoDB, and so on. Because we are running Postgres as our database, we're going to install the MPG SQL health check. And I'm also using Redis, so let's go ahead and install this health check library. How are we going to use them? Well, if we go back to our program file, let's say I want to configure the health checks before I add the events module. I will say builder services add health checks, and this will configure the general health check services. Now I also want to configure the custom ones that I added through NuGet packages. I will say add MPG SQL, and what I need to do is to provide a connection string to my Postgres database. Now I already have one, so I'm going to introduce a variable called database connection string. And now I can use this when configuring the Postgres health check. And let's also add a Redis health check, which is going to need another connection string. So I'm going to extract this into a variable. Let's call it Redis connection string. And let's pass this to the add Redis method. And this is all we need to configure health checks for our external services. You could go ahead and write these your own. All you have to do is to define a class that implements the iHealthCheck interface. So here's just a quick demo. And this interface exposes one method called checkHealthAsync. Inside of this method, you would access your external resource and implement your health check logic. Now in our case, we won't be needing any of this. We can leverage the existing health check libraries for our external services because they are well supported. One thing that we will need is to map our health check endpoint, or rather expose it on our API. So I need to call the map health checks method on my web application instance, and I can just specify the route where I want to expose this health check. Now by default, this is just going to return healthy or not, depending on the health checks that we configured. And we can add more detail by installing an additional NuGet package in our API project. And I'm going to look for ASP.NET Core Health Checks UI client. I will install the latest version of this NuGet package. And now if I go back to my program file, I can pass in a new instance of the health check options object. And here I want to set the response writer property. And I'm going to use a delegate that's available in the NuGet package that I just installed, which is the UI response writer. And I'm going to use the write health checks UI response method as the delegate for my response writer property. And now let's start the application, and I'm going to show you what we achieved. I'm going to send a GET request from Postman to our health endpoint that we just mapped. And if I send this request, you will see that we get back a 200 OK response. You can see that the status of our health check is healthy. And we have a few entries inside of our health check response containing the actual health checks that we configured. And you can see that here is the health check for MPG SQL or the Postgres database, and it is healthy. And then there is the health check for Redis, and it's also healthy. If I open up Docker Desktop and I stop the Redis container and the database container on purpose, and then send another request to the health endpoint, you will see that it's taking some time because it's unable to connect to the external services. And after a few moments, you can see that both of our health checks fail. So both the Postgres and the Redis health check have failed, and they contain some information about what went wrong. Also, the status of our health check is now unhealthy, and the response is 503 service unavailable. If I go back to Docker Desktop and start these containers again, and then after a few moments I send another request to the health endpoint, you can see that we are back to a healthy response because both of our external services are now functioning. And now I want to briefly discuss the actual value of adding health checks to your system. We need health checks mainly for monitoring purposes, as they give us an instant look into the state of our system and any dependent external services. Now, what is the value in this? Well, if something goes wrong inside of your system, You want to be the first one to know, right? And health checks can help you achieve this. It's much better that you find out that something isn't functioning rather than your customers sending you angry emails or messages. So how you can achieve this is by implementing an alerting system that you can integrate with your health checks. This system would periodically ping your health endpoint, and then based on the response, you can configure various levels of alerts. This is how you can immediately find out if something goes down in your system and react promptly. Another thing you can do once you have health checks in place is implement failover for your applications. For example, if your web API running ASP.NET Core is executing inside of a container, in most cloud providers you can configure a simple failover if the health check endpoint returns an unhealthy response. What this is going to do is it will spin up another instance of your application inside of a new container and redirect the traffic to the new container that should be healthy. And this is how you can use health checks for monitoring the state of your system and implementing high availability using failover. In this lesson, we talked about health checks, and I showed you how you can easily introduce health checks for your external services. We added health checks for Postgres and Redis using a few simple NuGet packages and configuring them with a few lines of code. And in the next lesson, I'm going to show you how you can automatically register your API endpoints. Welcome to the last lesson in the Cross-Cutting Concerns chapter, where I'm going to show you how you can automatically register your endpoints across all of your modules in a very simple way. Let me show you how we're going to implement this. Let's examine how we are registering our minimal API endpoints right now. We have a static class, for example, for the publish event endpoint. It's internal, which is good, which means it is encapsulated inside of the events module. However, we have a public map endpoint method, and there is nothing enforcing this convention. This method could have any other name. Also, it's injecting the iEndpoint route builder, but there is nothing enforcing this convention either. Inside of this method, we have a simple minimal API endpoint definition. This method for mapping the publish event endpoint gets called from the event endpoints static class, which is called inside of the map endpoints method in the events module. So there's a few degrees of indirection, but in the end, we somehow land inside of our events module, which gets called in the program file that ultimately configures our endpoints by passing in the web application instance. So what I want to do as part of this lesson is standardize our approach for configuring our minimal API endpoints and also make it internal to each of our modules. I'm going to start by adding a common project for our presentation layer. Let's go ahead and add a new project. It's going to be a class library, and the name will be Evently Common Presentation. It's going to be a .NET 8 project, and I'm going to update the project file to have a framework reference to Microsoft ASP.NET Core app. Then I'm going to update my existing presentation layer to have a reference to this project. So I'm targeting Evently Common Presentation, which means I can also update the project file here and get rid of the framework reference because we will be handling it through the common project. Inside of the common project, I'm going to add a folder called endpoints. Let's get rid of the default class. And then inside of this folder, I will add an interface called iEndpoint. This interface is going to have just a single method called map endpoint that accepts an iEndpoint route builder as the argument. And this is everything that we will need to define a simple endpoint. So how are we going to use this? I will go into my endpoint, for example, the publish event endpoint. It's no longer going to be static because I needed to implement the iEndpoint interface. And I'm just going to implement the method from this interface that I was already implementing by coincidence. So there are no other changes that we need to make here. The next thing I want to do is to move my API results into my common presentation project so that I can share the files inside between all of the modules in my application. The problem here is that we don't have a reference to the result type, and we can easily solve this by adding a project reference to Evently Common Domain. So let's go ahead and do this, and now everything compiles. If I go back to the publish endpoint, you will see that everything is still working fine, and I'm ready to do a refactor to adjust the namespace. So now I can use my API results type from the common presentation project, and I can reuse this in the other presentation projects in the new modules that we will be adding, and I also have a convention for configuring my endpoints. Now, how do we actually make this work with ASP.NET Core? I'm going to paste a file into the endpoints folder, which will be called endpoint extensions, and you can grab this file from under this video. And here I have two very simple extension methods. The first one is called add endpoints, and it's an extension method on the iService collection interface. So this is something that has to do with dependency injection. It's accepting an array of assemblies as an argument, and what's going on inside is we are going to take these assemblies, get the types that are defined inside of the assemblies, and look for ones that can be assigned to the iEndpoint interface. Then we're going to select these types and convert them into a service descriptor, where the service type is iEndpoint and the type that implements this interface is the service that we are interested in. If you think about it, this is going to be the publish event endpoint. Now if we go back, the next step is adding all of the service descriptor into the service collection, and this is only part of the story. The next method or extension method that we have is on the web application type, and what it's doing is accessing the service provider on the web application to resolve a collection of iEndpoint implementations. So the services that we are registering here, I'm now resolving as part of the map endpoints extension method. I also have an option to map these endpoints from a route crew builder, and this could be useful to specify any prefixes in the route, maybe configure API versioning. After we have done this, we're going to iterate through all of the endpoints that were resolved from dependency injection and just call the map endpoint method. And this will configure our minimal API endpoint. To make this work, we need to actually call these methods. So the add endpoints method, I will call directly from my events module. Instead of having a map endpoints method, I'm going to remove all of this code. And inside of the add events module, I can say services add endpoints, and I need to provide the assembly containing my endpoints. This will be presentation, and then I have an assembly reference type that I can use to grab the assembly instance. And this is going to register the iEndpoint implementations inside of this assembly, which in this case is the events assembly, and add them to the service collection. And then what this allows us to do is to map our minimal API endpoints by saying app map endpoints, which is the other extension method that we added, and this will automatically configure all of our minimal API endpoints. The next step is to update all of our endpoint classes to implement the iEndpoint interface. I won't make you watch me do this, I'm just going to do this behind the scenes and show you the results. So I have updated all of the endpoints to now implement the iEndpoint interface, and we have a few classes from before that we no longer need. For example, the category endpoint static class and the respective event endpoints and ticket type endpoint static classes that we were using before to map these endpoints. I'm going to delete these classes now, and we are left with just our endpoints that we have configured inside of the events module. There are a few things that I want to highlight. All of our endpoints are now internal to the events module, and we are only mapping them in one place. In the events module static class, I can call the add endpoints method, specify the assembly to my presentation project, and this will configure all of the endpoints for this module. When I add new modules in the future, all I need to do is to define the endpoints inside of a particular assembly and call the add endpoints method for that module. And inside of my program file, all of these implementations will be picked up from dependency injection and configured with our web API. Now let's start the application and make sure that everything is still working as before. With the application running in the background, if we navigate to the Swagger user interface, you will be able to see all of our API endpoints are still registered the same as before, so our new system for registering minimal APIs is working like a charm. And this brings us to the end of this lesson and also the chapter about cross-cutting concerns. We solved a lot of cross-cutting concerns that are going to help us move faster in the remainder of the course. We talked about health checks, caching, minimal APIs, dependency injection configuration, structured logging, and a few other topics. And we are ready to move on to the next chapter, which might be one of the most important chapters in this course, and that is module communication.